So welcome to this demonstration of the AQUASI framework. An open source framework, which was developed at the Duale Hochschule Baden-Württemberg in Mannheim, Germany, and which aims to deliver a basic framework for small and medium enterprises to enable simple Industry 4.0 applications based on a cloud infrastructure. The framework itself is introduced shortly at the beginning of this demonstration, and then we will show you how you can manage users in such an infrastructure, how you can enable the management of edges and cloud nodes, and the management of the runtime itself of the whole application. Before we enter to the details, let us first thank a few partners. First, the Baden-Württemberg Stiftung for the financial support of this research project, and the company Nurholz-Rombach in Oberhammersbach, which delivered us a very interesting use case for digitalization, which is the base of Industry 4.0 applications. The AQUASI framework provides functionalities, as mentioned already, to enable Industry 4.0 applications for SMEs. We did not do it for any application. We concentrated ourselves very strongly in the project on the development of quality assurance applications for individualized products. And the use case we had were a massive wooden house delivered by the company Nurholz. And the idea is how can we survive them over the whole product lifetimes, which is at least 100 years, I would say. We found out during the project that it's quite important to have a user and role-based security access mechanism, so we can secure the access to microservices. We delivered in the framework tools to manage a computing infrastructure from a cloud node to the edge node, to a gateway somewhere in the worldwide infrastructure. And that's what we want to do. We want to manage a worldwide infrastructure, a large distributed system with OSGI. This is the distributed system from a very high level. At the center of our system is what is called the AQUASI server or the framework server. Here we have basic services running based on a runtime which we called Inventors, which we show later. And we add there the basic services for managing the cloud, for managing users, for managing roles, and for managing the runtime Inventors itself. We will have backbone services, for example, a cloud storage system where we can have access, and we manage the access to an analytical systems on the cloud. So we might collect a lot of data from gateways. Gateways are one of the edges we have. So they might be located in the houses built by this company, and which deliver data about sensors in the house to the AQUASI server, uploads data to the cloud storage systems, and gives input to analytical services. So at the end, we will collect all the data, mainly in the AQUASI server, which is the knowledge database of the whole system. And we have edge devices, where we use also technology, the Inventors technology, where we can manage the user interfaces of all of these devices, in which we want to connect with all the other services too. All services are using REST requests, using HTTPS and JSON. And later on, which is not part of the system, we are thinking about accessing these REST services with other devices which don't run Inventors runtime. AQUASI is based, and that brings us to the base technology on OSGI, which means Java. OSGI, we use the tooling of Eclipse, of the Eclipse platform, and we use extensively also the provisioning platform P2. As mentioned, for communications, we build our communication is built on REST requests with JSON JAX RS, and for security, our part of our security is built on X509 certificates, which we use where we use Bouncy Castle to produce them. AQUASI delivers a framework server product, which we can run as a framework server, an RCP product, which will be run or can be run by many users, many instances, and which are therefore to maintain and to manage the system. We will have node product for edges in the cloud. We separate them under gateway nodes. These are nodes which more deliver data, and we have the analytical nodes which are running in the cloud to analyze the data which we have. Furthermore, we will have another software component, which is the software repository, which builds domain-specific, which maintains and contains domain-specific software in a P2 repository. And the idea is that with the RCP, we can install software from the repository on all the nodes, the server, the gateways, and the RCPs themselves. So what are the prerequisites if we start the framework? The whole system? Well, we need a key store and trust store certificates, which we have to have on different nodes and which is described on the web page of the project. In our demonstration, we use a framework server running in a network, but it's a plain server which we use to start from. And we need access to a cloud infrastructure with dedicated cloud image. Our cloud infrastructure is based on OpenStack, and that's what we want to use.